请听我说，请感受着我，所有你迷惘的我都懂，请让我在耳边唱歌，关于你梦中的理想国。空间时间交织，连成线融在身边，不知又不觉，眼看不见。难道这真的没有存在过来过？乌兰云烟，雷声和闪电，一朵昙花盛开在夜间。到底有点什么都不见，名为真相的幻影毫无意义，所有人只勾隔着一层多真实。若能感知胸口的呼吸，就该坚信脚下的位置都在重重的梦里，谁比谁清醒，他们不懂。停留是旅行，我要的只是我爱的人站在这里，我就守护这片土地。人来人往，皆是虚妄，看清楚你真实的形状。树影流星，万物的声音，飞鸟掠过天空，很平静。这些回应总胜过虚无缥缈的真实寰宇。天光云影，握紧的手心，诺言相约，心里的心灵都是假象，却让人爱着。名为真相的幻影本无意义，人却用心倾注了血肉和热情，心动一下，万物就下，人爱与否本无关真假，都在重重的梦里，何来清醒，只有真心。最真实无比，我要的只是我的歌声可以响起，而你的心可以感应。哇！Good morning, good afternoon, good evening. 早上好，晚上好，中午好。おはよう、こんにちは、こんばんは。So, I feel like I'm kind of slacking. So, let's head back and do some codings. We're gonna continue on to finish the 2-pointers questions. And here we go. Given an array of unsorted numbers and target sum, count all triplets in it such that array I, array J, array K is less than the target where I and JK are 3 different indices. Write a function, return the count of such triplets. Okay, so we have the input -1, 0, 2, 3. Target is 3. So we want to find triplets. Sum is less than 3. So there are two triplets in whose sum is less than the target. -1, 3, that's 2. -1, 2, that's 1. Download triplets such that the array I. Okay. Input is array of 5. The target is 5, output is 4. So 1, 1, 4, 1, 1, 1, 1, 3, 1, 1, 2. -2, 3. Okay, so if we pre-sort this, -1, 0, 2, 3, -1, 0, 2, 3. That's a terrible 3. 3. Say if we have 2 pointers, we're looking for triplets. So if we set I equal to this, we have left pointer, right pointer. So look at this number. If they are less than the target, then we push them into an array. If this is less, if it's less, then we increment the smallest value, and then we compare. Now it's bigger. If it's bigger, then we can end the... Wait, actually, no, we cannot end because this is only 4 numbers. So if there are more than 4 numbers here, there could be values here that's in combination will be less. So after we push a target value, we increment this left pointer and we compare again. Because now it's bigger, we push the right pointer. So now because the left pointer is equal to the right pointer, we move on to the next. So we now set I to here and then we compare this value. Zero, 2, 3. -1, 0, 2, 3. Actually, no. Wait, this is wrong. Because this is less than. It's less than, so we reverse the order. We should be going from 3 to 2. So now we have a 1, 0, 1, 2. Previously we skipped that. So this would also be less than the target. Okay, got it. So first thing we're gonna do is we're gonna pre-sort the targets. Array is equal to array.sort. And then for I, let I equal to 0, I less than array.length minus 1, I plus thus. This is our I number. And then we also need a left pointer. So left pointer would be I equal I plus, actually array length minus 1. Array length minus 1 is here. We need a minimum. We need a minimum 3 value. So I is at minimums So I should be the third last element. So instead of -1, I should be -3. So now this I plus will not be out of bound. So I plus 1. And then right would be the array.length -1. Should be the last element, the right side. Wait. Right. So are we leak coding? We are kinda leak coding. Not exactly leak coding, but similar. Coding challenge. Okay, so first thing we want to do is while left is less than right. So we wanna traverse. Oh, we also need a sum. Because it's just looking for count. This looking for count. So let count equal to 0. So while left is equal to right. Wait, I should set a maximum value. So val equal to integer there dot max value. Wait. JavaScript integer max value. Num.max. So num dot max save integer. Okay, so now val, because we need a temporary set of value, otherwise it'll be undefined. So you cannot compare a number in undefined. Value is equal to array I plus array I plus. Actually, I don't really need value. I don't think I need value here. Array I plus array left plus array right. And if this value is less than the target that we're looking for, then we pushed. Wait, we don't need to push. We just need to increment the count. If it's less than, we increment the count. After we increment the count, we move the right pointer to the left. Otherwise, well, what happens if it's equal? Count all triplets in such that if they're equal. What happens if they're equal? We're looking for smaller. Count all triplets in such that it's less than the targets. So it doesn't say anything about equal. What happens is equal. If it's equal, we're looking for a smaller number. Okay. If val is equal to the targets, then we do right minus. Right? else the last possible value is when the target is less than. So then we just increment the left pointer. Right, so we do this until the array is finished, and then we return count. Oh, they already said count. Okay. Run. Right is not defined. This. Run. Val is not defined. Oh, this. Run. Accepted. Submit. Okay. At least we passed the test case. Output 3, we expect 4. Step 4. If we pre-sort this, actually let me double check. Console.log array. Use this as test example. Wait. Negative 14213. Right, run this. Negative 14213. STDL is negative 1234. Okay. So I is this, left is this, right is this. We're looking for value of 5. Run. Negative 14, that's correct. So this is less than 5. This is less than 5. We increment value by 1, and then we look at negative 1, negative 113. That's less than 5, so increment by 1. That's less than 5, increment by 1. And then next we move this value to next. Oh, it's not doing 2. It's not doing 2 here for some reason. So instead of -2, I'm gonna do -2. Okay, now it's doing the correct one. Okay, so we expect 4. This is 3, right? And then 1 to 4. 1 to 4 is greater than 5. 1, 3, 4. Wait, why isn't the okay, 1 to 4 is greater. 1 to 4 is greater. So left should increment. 1, 2, 4. Why is it not incremented? If it's equal to, then we decrement right. If it's less than, we decrement right. If it's greater, then we increment left. So here 1, 2, 4 should be 1. Should be 1, 3, 4. Oh, 1, 3, 4. That's correct. And then 2, 3, 4. Use only 3. But they're expecting 4. 1, 1, 2. 1, 4, 1, 3, 1, 1, 2. That's correct. 1, 2, 3. Wait, there's only 3 value. Oh, 1, 2, 3, 4. 1, 2, 3. Oh, 1, 3. So 1, 2, 3 is less than 5. 1, 2, 3. Right, minus. So what if I do left instead? No, it's left. Damn! If we find a value, let's vary this. And we decrement this that. 1, 3. Okay. Can increment. Okay, so why is 1 and 3 not being? Is -2 supposed to be a -1? No, it's not. Because we are looking for triplets. So the minimum I has to start from here. If we do -1 and have I start from like here or here, this is no longer you can no longer satisfy a triplet. Therefore you cannot do -1. Because this is pre-sorted, so we're not looking for before. Okay, so now I think the question is like I'm looking for 1, 1, -1, 1, 3, and this is not doing that. So it finds 1, 4. Finds 1, 4. It's less than, right? So we decrement right side. And they should run again. But it's not doing that. Cleon plus, right minus. Why is it not doing that? If the value is less than the target, which in this case it is, so we decrement right side. So right should be here, but the next one is 1, 2, 4. It decrements the left side. Why? And it increments the left side. Wait. 1, 4. Wait. That's correct. 1, 1, 3 is here, and then 1, 1, 2, and we want 1, 2, 3. Oh. One, two, three. Okay, so edge case. Oh, 1, 2. How do I account for decades? The problem here is this handsome loop. The first inner loop. And we want them to continue. While bell is less than targets, left plus plus. So that's gonna Wait, what can I do? New? Blank? Negative 1, 1, 2, 3, 4. Target is 5. I is here. Pointer. This is correct. What happens if I reverse the order? No, if I reverse the order, I'm gonna missing other ones. So now here, a 1, and then 1, and then here, and then 1, and then they meet. after the meet. What if I like here one? I remember this position. Then check here. If it's greater than, I will reset and then do the thing again. I remember this position. Well, one. Chat is fancy rubber duck. Yeah, you guys are rubber ducks. And we don't want to do loop within a loop because that's gonna be exponential. That's gonna have exponential time complexity. Yeah, I don't have a good way to. If we remember this value, now we keep doing compare. Well, man. Then I don't have a good way to solve this. Help me, please. Unsorted, da 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 da. The only difference is that this problem within the VTubers is less than. To meet the condition that they are not equal. We have to make sure that it's never. So initialize 1, 4. So the equipment left instead. This is kind of reverse of. Wait, how is this 3?
target sum is equal to array I by 6. Oh, you don't have to traverse. You don't have to traverse this whole thing. Left once, right once. If you find one. Ah, I see. So, if you find this, because this is sorted array, so I and then left, right. If you know this leftmost and rightmost is already smaller, that means however you increment left. Oh, so previously we were gonna decrement right. We don't need to decrement right because if the biggest right value is already smaller than the target, then the sum of the left side of the right side is always gonna be less than the target value. So you just, in this case you find this, it's already 3. You can increment counter by 3. Oh. So if the value is less than target, then we can have the count equal to rights minus left. Count equal to count plus right minus left. And then we do left cross plus. Yes. Okay. So if I remove this now and submit this. Wrong. Missing one number. Why is that? One number. Count is equal to right minus left. Right minus left. Und 3. Or -2, -1, no 1, 2, 3, 4, 5, 6. I left pointer, right pointer. We're looking for 10. Because this is less than, we do 0, 1, 2, 3, 4, 5, 6, 7, 7. 0, 1, 2, 3, 4, 5, 6, 7. So we found this value. We comment counter from 7 minus 1, 6. So there are 6 pairs in here. So 6 pairs. So -4, -2, 6. That's less than 10. And then this less than 10. 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 It's 7. That is 7, 5, 7. It should be 7 pairs here. So, minus 1 plus 1. Wrong answer. This is 7 minus 1, 6. Right minus left. It's less than target. If it's greater than target, so both left and or greater should be plus plus. Otherwise minus minus. Greater than. One, 2, 3, 4, 5, 6, 7. Should be 7 pairs. 7 triplets. This part should give me 7 triplets. But according to this value, the count is equal to index. Index 6 or 7, index minus 2 is 1. So 7 minus 1 is 6. So plus 1 should be correct. Word is smaller than. Wait, why can I extend? Feel more. Then. So if you take this example, if we take a smaller example, minus 1, 2, we found that, and this is 2 minus 1 is 1. So this is correct. So if we add one more number here, 3 minus 1 is 2. But it should be 1, 1, 2, 1, 1, 2. That's correct. And then what is the 3 number? 3 number is 3. 1, 1, 2, 1, 1, 2, 1, 1, 2. That's correct. Wait, hold on. 1, 4, 6, 4. That's 1, 2, 3. 4, 5, 6. 6 is correct. 6 is correct. But I'm missing one number. So this is correct. So the problem value is here. So on this, we found this, right? So we increment value of entire row here. So this will be 6. And then we increase this. And then it's also less than. So we increment the whole value. And the next one we go to 2. 2 is also less than. We increment the whole value. We go to 3. We go to 3. This is still less than 10. We're gonna use this as example. And then run this. Huh? Wait. I'm gonna use this as example. Oh, this is the middle one. Wait, no. That's not the middle one. They are not the same, but over here. So, we find the first left, right, increment by 6. That's correct. We find the next left, right, increment by 6 plus 5, 11. That's correct. We find the next pair, increment by 4. That's correct. We find the next pair, increment by 3. That's correct. We find the next pair, increment by 2. We find next pair, increment by 1. Yeah, this is less than 10, so this is correct. And then we increment I. We turn I into -4. So -4, 1, 6. Oh, -4, 1, 6. -4, 1, 6. 1, 2, 3, 4, 5, 5. -4 plus 5, that's correct. And then plus 4, that's correct. Plus 3, correct. This is equal to. Wait, no, that's not equal to. That's correct. Still less than 6 per increment 1, that's correct. And then we move on to the next. 1, 2, 6. 1, 2, 6. 6 minus 2 is 4. So increment by 4, that's correct. Wait, no, not 6. 6 is index. 1, 2, 6. 1, 2, 6. 1, 2, 3, 4, 4. 4 value. So increment by 4, that's correct. 1, 3, 6. Well, 3, 6 is equal. If it's equal, then we move the right side. Here, this triggers. And this is less than, right? 1, 3, 5. 1, 3, 5. Wait, hold on. 1, 3, 5. Oh, 3, 6. So 1, 2, 6. is complete. Increment 1. 126. 136. Little 126. That's complete. So R now should be 2. 136. If we find this, then we break out. Left, even left. Beam. Infinite loop. So something is wrong here. Damn. It's already you comment that and then you mark plus that. You comment this. Correct. Move next. Correct. Move left. Correct. That's what I'm doing. What's going on here? What is going on here? That is what I'm doing. If you find the target, then the entirety from where the left pointer to right pointer is, everything included should be also less than the target, and then we increment the left side, which is here. Right, but if we find the equal, if target is equal, then we -1. This less than, if target is greater than. Wait. I don't get it. I do not get it. It's less than 3 that you see return because he cannot make a triplet within erase. So that's true. Wait, hold on. Was I not sorting correctly? Sort? A matter. Or hold on. Sort is if we want to solve from smallest, is A minus B. Was I not so? Oh, do I? A B. A minus B. What happened if I do that? That's still the same thing. Never mind. Array targets minus array I and I. Array targets them first. Yeah, that's one thing. First. It found a triplet. If you find a triplet, it's equal to right minus left. That's correct. Otherwise, you need a smaller sum. Isn't the same here? You find that is increment left. You find that increment left. Oh, they're not even looking at the target equal. So if I remove this and have it all right minus minus. Wait, what? The fuck? Hold on. Hold on. If they are equal. Oh, I was incrementing right, left here, so that was wrong, but even this to be the same. If val is equal to the target. I don't get this. If this is equal, then we write minus minus. So this should be the same, right? Wait, no, it's correct. Who? Wait, what did I do wrong here? If, else, if, else, if. What was it? What was it before? Equal to target, right? Because I also changed this to right minus. Wait! Why? Why is it? I already did that before. I did. You saw me did that right minus minus before? And I still had the error? Huh? What the fuck? I did this right. I did this earlier. Then I submitted the thing. We have done nothing, but it works. Proceed to the next duck. Damn. Dude. Oh, don't need console log anymore. So the whole console log takes 0.001 milliseconds. Damn. Okay, I'm gonna get water. Be right back. You know LSP right minus mask. You are correct. I just saw your message. You are correct, and I tried that. For some reason it didn't work. Maybe I should rewatch my own video. For some reason it didn't work in the first try, and so that's why I did. That's why I was wondering why. Wondering why it didn't work. Next. Next. Okay. Counting subarray with product less than the targets. Given an array of numbers with positive number and positive integers, targets, return the count of continuous subarray whose product is less than the target number. Example, if increase this target is 30, output is 6. There are 6 continuous subarray. If less than target. Oh, so each individual is one of them. So 2 is less than, 5 is less than, 3 is less than, 2, 5 is less than. Why is it not top 3? Wait, I don't get this question. Positive number count of continuous subarray or continuous subarray. Oh, so 2, 3 cannot be the one because 2 there's a 5 in between. So in this case, we cannot sort this band, and they have to be like in a very continuous. Wait, but then 2, 5, 3 is less than that. I still don't get it. Continuous subarray. 2, 5, 2, 5, 3, 5, 3, 10. That I can understand, but why 2, 5, 3 is not? That's still a subarray of the array. With product. Oh, product. You mean 2 times 5 times 3. Oh. Okay. Seven continuous. Two, 5, 3, 10. 2, 5, 3, 10. So let's say 2, 5, 3, 10. If I make I equal to 2, if I is less than, we increment count. And then I left pointer, right pointer. Do we even need right pointer? So I times left pointer is less than increment by 1. And then we increment this pointer. Product of this is greater than. If this is greater than, then we increment I. Do we need the no shit. Yeah, we increment I. This is not sorted, so we need to look at all the numbers. And because 5 is less than, we increment this. And then 5 times 3. And then 5 times 3 is less than. Less than. Increment that. So we look at next number. And if the next number is greater than, we increment I. Now 3 is less than, increment. And we look at the next number. And if the product of this is not, then we increment I. I by itself is less than. And we look at next number. There is no next number, so we end the loop here. So now this is 6. By 6. Product 6. Okay, got it. Okay. For let I equal to 0, 0 I less than nums dot length minus 1 I plus us. If nums I is less than targets, if this is less than targets, then total count plus plus. And then we can start looking at left way. Let's left equal to left equal to I plus 1. If I plus 1 is greater than or equal to nums dot length, then we have reached the end of the array. So we just break this out. If it's greater than, if it's less than, oh, I see. What happened if so once? If it's greater than, we end the array. While it's okay. Here's the issue here. We know this we can do the increment by 1. So if we can set it as the right pointer and then left pointer and right pointer and then keep adding pointers to here until we hit it's greater than, right? So this is okay, but we need to make it into a while. We need to make it into a loop, because if we can have edge cases like this. So 2, 5, 3, 1, 1, 1, 1, 1, 10. So all these ones we need to keep looping these ones for as long as it's less than the product is less than the targets. So that's why we need to have a while loop here. So while we need to get a product here. So let's product equal to nums I. If product is less than targets, then we increment that. While product is while product is less than targets, we increment this value. So now the new product, the product is equal to product times nums I plus 1. We need to do this first. If it's greater than the length, we break out of this while loop. So we keep adding num is equal to this plus 1, I plus 1 product. So after this, if it's still less than the targets, we incremented that again, and we move on to the next. Oh. So instead of R, we need a... we need an increment. Let increment equal to I plus 1. Okay, so the increment, if it's greater than the length, we break it out. Otherwise product is equal to product times the increment. So after this is incremented, so we first 2, 3, 4, 2, 5, 2, 5, right? First rule be 2, 5. Product 2, 5 is less than 30. So we increment again. So now I is equal to I plus 1 again. So this here. So we have 2 times 10, then times 3. Yeah, so while products, this should be fine. And well, according to this is wrong. Wait, there's a button here. Product is equal to I, which is 2. While product is less than targets. So this is true, increment by 1. And then this is equal to 5. But this is 2. This is index 1. Index 1 is less than the length. Right? And then we product, the new product is now 2 equal to, wait. The first product is 2. The second product is 2 times num increment, which is 5. Alright, so if we just print out the product here, run. 2 versus 2. 2 to 5 is 10, right? So we move on to the next. 2, 5, 3 is less than, is greater than the targets. So this breaks out. So 2, 10. That's 1. So next one is 5. 5, 3 is 15. 5, 3 is 16. That's correct. So 5, 3. And next one is 3. Also, we're missing the last value. It's 10. Oh, less than. Instead of -1 here. It's solely less than, so we do this instead. Correct. Submit. Wrong. 1, 2, 3. One, 2, 3. 1 is greater. 1 is correct. Wait, 1, 2, 3 value is 10. Okay. So 1 times 2 is 2. 2 times 1 times 2 times 3 is missing a 6. Wait, this doesn't make sense. Where did that 4 come from? I is 1. I is put down 1. Less than 10. Increment. So this is 1. Increment is equal to I plus 1. So this set this. So now the product is equal to 1 times 2. Which is 2. So we print out the product again, 2. That's correct. And next is I plus 1. Would be 3. And product is equal to 2 times 3. This should be 6. Why is this not 6? Increment is 2. Oh. Like increment What's this? Oh, cause I'm not incrementing the increment. Let increment equal to I plus 1. Cause this keeps resetting to I plus 1. Increment plus plus. Cause this is inside the while loop, so this keeps resetting the increment to I plus 1. That's why it's not doing that. Okay, got it. So now it's correct. Submit. Yay! Ah! Finally. This is getting easier and easier. The solution is correct. So this is basically what I said here. First we declare increments. So the first product is always the first value, I here. If this first value is less than the target, then we can keep incrementing. We can keep looking ahead into the next value. And then we have the product always have the product times that next value. And then we increment the next value. So if this is still less than the targets, then we look ahead into the next value, which is from this increment. Alright, so if it's less than, we increment the count, and then we have the products of the previous product times the current increment, the current pointer times the current pointer value. And if this product of the previous product times the current increment value is still less than the target, then we keep counting, and then we increment the increment again until the product is less than the target. So now we can move on to the next I. We do that until we reach the end of the array, because we always look at the I as individual number. So the first product will also always be the individual number I here. Okay, it's getting easier now. Nice. So basically what this says, visualized, left right, left iteration, second iteration, the product. So the first iteration is the product is less than. So you move the pointer. And then look at the product. The product is still less than the target. You move on to the next pointer. So now the product is the product of all three of the value here. It's less than. So you start moving the I. You're moving I. In this case, it's base left right. You start moving I to the next value, and then you look at the product. Because the product is less than the value, so increment the right side. Increment right side, and then you look at the product again. and then because this is less than, so you increment I into the next value and look at that value until you reach the end of the array. Okay, there. I don't know. Shall I continue? I'm gonna stop here. I'm probably gonna schedule something else to play. Maybe. Anyways, we did 2 medium questions, which is okay. Pretty good, I guess. Enough. I need to do something that does not involve brain activities. So I'm gonna go shoot something. And see you guys later. Bye bye. By shoot something, I mean shoot something in a video game. Bye bye.
中的理想国，空间时间交织，连成线融在身边，不知又不觉，眼看不见。难道这真的没有存在过来过？乌兰云烟雷声和闪电，一朵昙花盛开在夜间。到底有天什么都不见，名为真相的幻影毫无意义。所有人只